this video I'm going to review some right triangle trigonometry. The main idea behind right triangle trig is similar triangles. So for example, we've got a right triangle ABC with a right angle at C and a 50-degree angle at A, and a right triangle DEF with its right angle at F and a 50-degree angle at D. These two triangles are similar, and if triangles are similar, the ratios of the corresponding sides would be equal. So for example, the ratio of side A over B would be equal to the ratio of side D over E, because in similar triangles, the ratios of corresponding sides are equal. Now this idea holds true for every triangle that has a 50-degree angle and a right angle. All of them would be similar. And so these ratios, or these constant ratios, are known. The ratio of what the side opposite of the 50-degree angle compared to the side adjacent to the 50-degree angle is always going to be the same for right triangles with a 50-degree angle. And the same would be true for a 40-degree angle, 30-degree angle, 20-degree, or any angle that you can come up with as your angle that you're looking at there. So similar triangles is the main idea. There's three functions that we focus on with right triangle trig: the sine of an angle, the cosine of an angle, and the tangent of an angle. Now they're defined. Sine is defined as the side opposite the angle over the hypotenuse. The cosine of an angle is defined as the side adjacent to the angle over the hypotenuse. And finally, the tangent is defined as the side opposite over the side adjacent. There are other ratios, but typically in a geometry class, these are the three that get used, and they're enough to solve really any right triangle trig problem that you're given: sine, cosine, and tangent. Okay, so for example, we could use the sine of angle A to solve a right triangle if we know an angle and really any side. So let's go with the hypotenuse being 10. So we can set up an equation using the sine or the cosine. We really don't have enough right now for tangent to solve for either of these sides. We'll call that A and that B. A is the side opposite of angle A. B is the side adjacent to angle A. And 10 is the hypotenuse. I should have said leg adjacent, actually, because that helps me identify it separately from this, because actually both of these sides do touch angle A, but this is the leg adjacent, and that's the hypotenuse. The hypotenuse is typically the easiest to find because it's always opposite the right angle. Alright, so if I wanted to solve for A, the side opposite of angle A, I need to look at also what I know, and that's the hypotenuse. So I'm looking for the side opposite. I know the hypotenuse, and I look at my three functions. Sine uses the side opposite and the hypotenuse. So I can say the sine of angle A is equal to A over 10. Now angle A is 50 degrees. So the sine of 50 degrees is equal to A over 10. Now, the sine of 50 degrees, it's a known ratio. It is known, as I was saying before, all right triangles with a right angle and a 50-degree angle all have that same ratio for the side opposite to the hypotenuse. And that ratio you can get using your calculator by just simply typing sine of 50 degrees. So the sine of 50 degrees, and be careful to check the mode. Your calculator probably has a radian and degree mode. The sine of 50 degrees is approximately 7.7660 So that's something we know. Sine of 50 degrees is not a variable. It is a number that we can use in solving our equation. So the sine of 50 is 0.7660. It's approximately equal to a over 10. And now I just need to solve for a by multiplying both sides by 10. 7.660 is approximately equal. Alright, so that's the sine, using the sine to solve for a side. You can also use cosine to solve for side B. Now, technically, I now know two sides of the right triangle, so I could use the Pythagorean theorem to solve for the third. But, to practice trig, I'm going to use cosine. And also, as I was saying before, this is a rounded answer. To use a rounded answer to solve for my third side could cause me to lose a little bit of accuracy. So I would suggest still using trig. Alright, so if I want to solve for side B, that's the side adjacent to the angle. And I know the hypotenuse. Now, yes, I do know opposite, but again, that was a rounded value. I like to go back to the one that was given in the beginning. So I know the adjacent, or I'm looking for the adjacent, sorry, and I know the hypotenuse. Adjacent to hypotenuse is cosine. So the cosine of 50 degrees is equal to b over 10. Adjacent over hypotenuse. And again, go to the calculator, making sure I'm in degree mode. Cosine of 50 degrees is approximately 0.642 times 10, and that is 6.42. There's 1,000 would be, that's approximately equal to b. So I have now found my other side lengths of this triangle by using right triangle trig. I used sine and I used cosine. I did not use tangent in this example, but it would be the same idea if I knew a and wanted to solve for b. Set up an equation. The tangent of 50 is equal to a over b. One other thing that you can do with trig is instead of using this angle, you could, since we know all the angles of this triangle head to 180 degrees, use this angle. So 40 degrees is angle B, but we have to be careful with that. The hypotenuse will remain the same, but opposite and adjacent change. Opposite of the 40 degrees, angle B, is side CA, and adjacent is side BC. It's the leg that is connected to angle B. So I could set up a trig equation now using sine to solve for side B. The sine of 40 degrees is equal to the opposite over the hypotenuse, B over 10. Multiply both sides by 10. Go to the calculator, and I should expect to get the same answer I had before when I was solving for B. It's the same triangle, 10 sine of 40. And as I had before, no surprise, 6.427, 28. So what we can do is we can use either of our non-right angles to set up a trig equation to solve for the missing sides. The thing you need to be careful about is when you label the opposite and adjacent. I'll show another video later how to solve for angle measures using trig, but for now that is just using right triangle trig, sine, cosine. Didn't use tangent, but it's the same idea, just a different function to solve for missing sides of a triangle, right triangle.